So selecting now is obviously simple. When I select, I get back the reference. And I take the reference and create a full URL out of that by adding the host name or IP address and the port, and I can retrieve that blob data from the repository. Okay?
So the my reference table, when it showed now it is a
Yes.
permanent blob, is that a static table?
No, those tables are both dynamic. They're getting their information out of information that's stored in the repository, but not in a table form.
Okay. So if I update the primary ID from 1 to 2, just directly going to the table, it automatically reflects here?
Yes, it would. Okay. So the client-side extensions. JDBC works. So you can do this with JDBC, and the great thing about JDBC is the whole blob streaming stuff that I've just demonstrated you by hand is completely transparent. That is because JDBC already supports set binary stream and set blob and get blob, the functionality for streaming. So all I did to modify the current JDBC or the JDBC driver, the standard JDBC driver, was to modify the implementation of these functions. And I'm working with MySQL now to actually get that included in the standard, the current GA release 5.1. Not quite sure what the minor number is, but it's 5.1 something. And we'll have a Google Summer of Code project, at least I hope we will this year, which I will be mentoring to add extensions for blob streaming to PHP. There's still a bit to be done though. The standard C library of MySQL requires simple functions to get and put data. ODBC already has a SQL get data, put data, which are the correct functions to stream the blob data. They would just need to be otherwise implemented. Just like on the JDBC driver, of course, there's a switch to say, do I want to stream the data or do I want the standard behavior? So it's not like you... that's important, obviously, to be able to... you can't replace the old behavior because, the one needs the blob streaming engine, and the other is standard behavior. And we'll also be adding extensions to Perl and Ruby and the other connectors that MySQL supports. Right, so on to the advanced stuff. I'm doing well for time here, so we'll have time for questions. Do you have a question now?
Let me ask one question.
Yes.
So we didn't discuss security on the HTTP.
Yes. Okay. So the question is, what about security on the HTTP? I didn't mention that. You saw that currently the security is based on the fact that this URL, the reference that's being generated by the repository, has as the largest component, I didn't say what that was, a random 4-byte number added to it. So the repository, for every blob that's uploaded, besides the reference information that it needs, it adds a random number to the URL. So there's actually no way you can, we can't protect the port. So you can probe the repository for blobs. We can't prevent that. Obviously you would put the blob streaming engine behind the firewall, and you would actually proxy over Apache to the blob streaming engine. So you wouldn't expose the blob streaming port directly to the internet. That's the one thing. But even if people probe it for various references, they're very unlikely to hit a valid reference because of this huge random number, which is part of the reference, which has to be correct for the blob streaming engine to actually return a data to you. Okay? Does that answer the question? So how does backup work when, as you saw when I did a select, I just got the reference out, no data. So how would, for example, a MySQL dump work in this case? Well, MySQL dump will also actually dump the repository system tables, the MyBS repository and reference tables. So in effect, by dumping those tables, all the data that I need to reconstruct the repository is in the dump, with the one exception that the dump, MySQL can only dump, I think, 2 GB data. So if you've got blobs in the repository that are bigger than 2 GB, then that won't work. But then there are other backup mechanisms that do. And the only thing that's missing in this is that to restore such a dump, the system tables will have to be writable, and this still has to be done. So that would be the case when I'm actually inserting into a MyBS system table instead of using put to upload a blob to the repository. And how does replication work? I've already explained this the first part of this, where you put a blob in the repository, get back the reference, place the reference into the insert statement, and then this retain happens automatically and transparently. So you can see clearly that the data uploaded here, well, MySQL itself, the main server, knows nothing of that. That's gone over a separate and a different channel to this insert here, which is the standard client-server protocol. And because MySQL doesn't know anything about that, it also hasn't put this data into the binary log. So what happens when it's replicated? Well, when it's replicated, of course, just the inserted data is replicated. So it's replicating the reference to the blob. And when it gets to the slave, well, the slave does the same as what the master does when it is inserted a reference. It calls retain on the engine, on the BLOB streaming engine. And now one part of this reference is also here. This number, the last number, is the server ID. And using the server ID, this repository recognizes that this blob is not actually in its repository, but in another repository somewhere else. And it looks up the IP address of that repository, because it's got a table which maps the server IDs to hosts, and simply gets the blob from the other repository, like that. And now this get can actually be done asynchronously. So instead of having to, it doesn't actually have to hold up replication, which is continuing here at this level. It can start several threads to pull blobs from the other repository while the normal replication continues. So you don't have the same kind of problem that you have with replication of blobs today, where actually everything is serialized. And if you're replicating a lot of blob data, then the slave can really struggle to keep up with the master, which is receiving the data in parallel.